Alrighty, well, let's get this going. My name is Josh Parker. I'm an outside rep here at BayWa. I would like to introduce Chris Ling, the applications engineering manager at APsystems. I've had the pleasure of taking a couple hands-on trainings with Chris, and he's a really good resource with a bunch of knowledge. Not to set the bar too high for you there, Chris. In my time here at BayWa, I've had the pleasure to learn and grow with APS. They truly are a great partner with quality products you can rely on to do exactly what they're expected to do. I'm happy the team is here with us today to deep dive into their products. Continuing education is important with BayWa. We really do appreciate you attending and taking the time out of your busy day to join us in APsystems. If you have any questions, be sure to type them into the chat box in the bottom right corner. We'll answer questions as we go here as they pop up, and then we'll also have a Q&A at the end for anything that might have missed. If I can get a favor, can I just get somebody to type in test into the questions chat there just to make sure everything's working? Lastly here, just a reminder, this is going to be recorded and shared on our YouTube channel, as well as sent out in our monthly newsletter. If you haven't yet, we encourage you to subscribe to our YouTube channel. You'll find all of our past webinars on there. I will pass over the reins here to Chris. You can take it away.
Thank you very much, Josh. Give me a couple seconds to pull the screen. Oops. Well, that's definitely not what I want to share. Okay, just want to confirm this looks okay in terms of your guys' sign.
Yeah, looking good here, Chris.
Great. Okay, thank you very much. All right, thank you very much for the introduction, Josh, and the BayWa team. As mentioned earlier, my name is Christopher Lane. I'm an applications engineer at APsystems. And today we'll be going over a multitude of topics with regards to new products, QS2, AC Combiner, our ELS battery,
Hey, Chris,
and also
we're just seeing the PowerPoint presenter slides in the back here. It's not just on one slide, yeah.
Okay, bear with me 1 second to see. How about this? Does this look better now?
Perfect, that's looking good there.
Great, thank you very much. All right, so yeah, so just to oh shoot, this is okay. All right, cool. So we'll be going over some new hardware that we have coming out with APsystems, and I'll be going over a little bit more information about our company as well in terms of new developments that we've had coming in the background. Just as quick information, I'll just do some quick boilerplate information. So this has been our history with APsystems. We started our company in 2010 in Jiaxing, China, and then we have a pretty large global presence, as shown in this map over here. Different business units in the US, in Canada, Mexico, Brazil. In Europe, we have them in France, Netherlands, Australia. And as mentioned earlier, our headquarters is in Jiaxing, China. It's about like 2 hours away from Shanghai, if you guys are curious. And as mentioned earlier from this timeline, we had a pretty storied history where we started out doing our microinverters. And then we started expanding with other projects such as our rapid shutdown device and our battery system as well. But one thing that has been really nice, I just want to mention, is that we had recently celebrated our 15th year anniversary last year. So we're coming up on the 16th year very soon. So I just want to reiterate that these 15 years and almost 16 years has only been possible with the great partnership and support of you as customers, and also with BayWa, as well as being a great distributor partner for APsystems. So on behalf of APsystems, I want to extend much gratitude for your support. And our hope is that we continue to serve your needs so that we have both a mutual benefit. So here's an overview of the main topics that I'll be going over. First, I'll this is probably information that you guys have heard many times, but I'll just go over a little bit of our product architecture of our microinverters, the DS3 and the QG2s. Second thing, I also want to do a slight addendum with regards to talking about our commitment with regards to product quality and technical support. And then afterwards, we'll go over some new hardware. So that includes our QS2, our combiner box, and our PCS. I'll go over. I don't know if I have time for this, but I'll do my best. I'll go over a couple of new features that we released on the eMay app and on the eMay website. But I do want to focus on the top three topics that we want to go over for today. All right. And as Josh had mentioned, for me personally, I enjoy questions, especially any ones that and because I want this presentation to be for you as the customers first and foremost. So if there's any sort of questions, feel free to type it into the chat box, and I'll pause frequently and ask Josh if there's any questions that are coming up. All right. So first thing I'll just go over, a lot of this information should be relatively straightforward, especially for people who use APsystems. For us, our main product line that we use is the DS3. And this image shows the DS3S and L. They're pretty much the same hardware with the exception of a couple. Well, they're pretty much the same with the exception of different power levels. And the microinverters are responsible for producing power from the microinverters, from the panels by taking DC voltage and converting into AC. Another piece of this architecture is the ECU, which is the gateway responsible for collecting data from the microinverters and then uploading it into the internet. And then all the data on the internet is accessible using our EMA platform, both on the website and on the app. Similarly, in a residential solution, we also have a commercial microinverter solution, which is the QT2. So it's very similar architecture to the DS3 with a couple of exceptions. One is that it is 4 panels instead of 2 panels. It uses the same ECU, same monitoring platform. But the really nice thing about this microinverter is that it's native 3-phase. So it's not like a solution where you have single-phase microinverters and then you're putting them onto and you're balancing them onto every 3rd phase or something like that. So on its own, it's able to produce 3-phase natively. What's nice is we have a 208 and a 480 version. So now at first glance, like the QT2 seems kind of strange for like a commercial 3-phase project, because I think the initial gut reaction is that if you have a microinverter solution for a large commercial site, it seems to be pretty high. It seems to be a cost prohibitive solution. But I do want to go over a little bit in terms of the key reasons that you would use microinverters for commercial. So first of all, this is a true low voltage system. So if you think about for a string inverter or some sort of optimized or for a string or centralized inverter solution, you're putting a bunch of panels in series, which means that you're going to have large DC voltage buildup. The huge risk of having high DC voltage is that there is the risk of high voltage DC arcing, and that's something that you want to be like absolutely sure. If you do the installation correctly, then of course that won't be a problem. But there's always like a risk that you always want to be sure whenever you're doing an install, and you just need to make sure that does not happen. Whereas for a microinverter, just by the nature of its architecture, you don't get any sort of high voltage DC at all. And because you have there's absolutely no presence of high voltage DC, there's basically no risk of any sort of high voltage DC arcing because it doesn't even exist in the first place. So it is a true low voltage system for safety. Because if you're thinking about it from a microinverter system, the only DC voltage that you will get is a single panel DC voltage, which is like at most 60 something volts, 60 volts as per NEC code. Another thing that's also important to note is that if you think about from an inverter failure perspective, the impact is much less. So the worst thing that can happen for a microinverter is that if it goes down, it takes down 4 panels for the QT2. But then for a centralized or string inverter solution, if the string inverter goes down, the entire string goes down, or the entire array goes down. The multiple strings inside the inverter. So the response time and the impact of failure is a lot more catastrophic. Another thing that's also I would like to mention as well is that you can also get module level monitoring as well for the microinverter solution. Once again, not useful for every customer, but if you have a customer who demands this level of monitoring, this is one way of accomplishing that by using microinverters. what's nice is that you'll be able to pinpoint what particular module or microinverter is having those issues. So instead of only being able to track down to a single string, you'll be able to be a lot more modular in terms of, and being more specific in terms of where you can get your information. So those are higher level architecture reasons for microinverters. Hopefully a lot of this is review and familiar to us all, but I just sort of wanted to reiterate these are the things that we often think about from a microinverter company. Any particular questions? If not, I'll go over product quality.
Yeah, nothing popping up for questions right now, so we're good to keep going.
Great, sounds good. Thanks, Josh. All right, next I'll talk a little bit about our commitment for product quality. So first thing I want to mention is that because these microinverters are under the roof, it's really important that they need to be able to stay, they need to be environmentally protected and have strong reliability. So one thing that we do from an engineering perspective is that we pot the inside of the microinverters. What that means is that we inject it with a sort of like a goop like substance that hardens, and then that potting material does a lot of different things because it protects all the electronics from any sort of shorting or any sort of like outside contaminants causing problems to the system. It helps with cooling also because now that you have sort of a material on the components itself, it's able to dissipate and transfer the heat from the components to other things as well. It's NEMA rated, and then the operating temperature is a -40 to 65 C. If it does go outside of those temperature boundaries, the microinverter will actually throttle, so sort of reduces power a little bit so that it doesn't overheat itself. And then when it goes back to normal operating temperatures, then it can start ramping its power back up again. One thing I'll mention is that I think just to be slightly transparent, when we first released the product, we had some pretty high, pretty how to say, higher than we would like failure rates for our batches. But I do want to say, and I do want to be proud of mention from that with our newer product and with our current line and current deployments of our microinverters, our failure rates are less than 1%. I would even say less than less than like 0.1 for certain batches. But then we've definitely did a lot of iterations, and our failure rates have really come down. And we would say we're very proud of that figure. One thing that we also do as well is that we do third-party evaluations. So we've been evaluated by two organizations, the DMV and RETC. Both of these companies, they not only so DMV or RETC looks at our products, they take our products and they perform testing, reliability testing, and compliance testing on our microinverters to ensure that they're good quality products that operate as the way they should. And then the DMV, they not only do a review of our product, they also do a review of our company from a bankability perspective as well. So yeah, and then so both of these reports, both of these reports say that they do believe in the quality and performance of our microinverters. We also recently, I think it was around last year, that we now have 25-year warranty that comes with our microinverters when we ship them. So that basically underscores our long-term availability commitment. And I think this one is kind of an interesting side point, but I will mention this because I think this is probably one of the most common issues that we often run into the field, where a lot of people often think that it is the microinverter is performing incorrectly or having problems, but in reality, it's actually a setting on the microinverter that is required for us to set in order to comply with grid regulation. So I'll describe this phenomenon. So if we look at, let me see if I can pull up pointer. Great, yeah. Okay, so if you look at this section over here, where you notice that like the power of the microinverter kind of comes up and down, and it kind of cuts off right over here. So at first glance, it almost looks like the microinverter is not able to produce power because it's broken. But actually, a lot of times is that I want to introduce the concept of something called AC parameters. So what it basically means is that a microinverter is only allowed to push power if it sees an AC voltage. So 240 volts is usually what it expects to see. But then of course it's not going to be exactly 240 volts. There's going to be like a range of acceptable numbers that the inverter can push power to. And a lot of times is that those ranges are actually set by the utilities. And we also have default values to those parameters. So those ranges is set by default, but it's possible that depending where you are, depending on the grid quality, that the voltage at those ranges can exceed the ranges that the microinverter is currently programmed at. So for example, over here, if you notice this, a microinverter is hitting like 266 volts, either because of voltage rise effects from the wiring or from other things. Maybe the grid is maybe you're at the end of the line of the utility, so the grid is a lot more unstable. So a lot of times is that if it exceeds that voltage or operates right over here instead of the ranges that we set, then it will turn itself off just to keep its just so that it keeps within its own self-programmed safety limits. However, it is possible for us to expand those allowable parameters to basically tell the microinverters like, oh, you see 266 volts, you can actually operate it a little bit higher. So that's something that we can do, is that we can go into the microinverter and expand those AC parameters. So that's one thing that we often recommend that customers do, is that if they do see an issue where the microinverters are cutting out in a manner like this, it's possible that is an AC parameter settings that we need to adjust. So definitely give our tech support a call or send them a ticket, and then that could be something we observe to see if it's an AC parameter issue that we can expand so that the microinverters can function. So that actually leans onto this slide over here. This is our technical support number. I highly encourage people to give a call to this number if you're on site. If you're not on site or if you're in the office, we generally recommend calling during non-peak hours. So usually beginning of the shift is probably better, is what I would recommend. Or sending an email inquiry. There's a support form on our website that you can submit, and then we'll be able to take a look at it as well. So one other thing I will also mention is that we did recently revamp our technical support team. We used to have a lot of technical support responded based in agents based in China, but we recently built up our local. Actually not local because it's not based in Canada. But they are based in the United States. So there are like English native speakers who have a large wealth of experience in technical support. Our technical support manager is Mel Thompson, and she's been with our company for almost a year now, and she brings a large wealth of experience in terms of providing technical support for microinverters, as that is her past experience as well. And she's built up a team to be able to help build a technical support team in Canada. So it's something that we are serious and want to commit to, that we have a strong technical support team that can help you guys out. One other note also is that we, around a year and a half ago, or a year I want to say, we have now a warehouse that is dedicated to our shipping RMAs. It's based in Edmonton, Canada. So a lot of our RMA shipments have been a lot faster now that we're shipping from the Edmonton warehouse. All right, any questions regarding this topic? Otherwise, I'll move into more interesting topics about new hardware.
Yeah, no questions coming in yet, Chris. We can keep moving here.
Cool, sounds good. All right, so now let's go to the more interesting topic. Maybe the previous topics were interesting, but let's talk about new products that we are releasing. So this is the QS2. If people are familiar with APsystems history, you might have heard of the QS1. The QS1, Q stands for quad, S stands for single phase, 1 stands for first generation. So as you can imagine, the QS2 is the second generation. So what's nice about the QS2 is that it's using the same Zigbee platform. So if you have a customer with a mix of DS3s or our YC600s that uses Zigbee, you can use the same ECU to be able to work with the QS2. Unfortunately, YC500s, since those are PLC based, they will not work for this. But then for our for our second and third generation microinverters, will be okay. Just be cautious about the if you do mix the trunk cable, or mix the microinverters, just be very careful about the AC power rating. So the QS2, the AC output power is 1920, and that basically allows you to put exactly 3 of these QS2s on a 30 amp breaker, or 2 of them on a 20 amp breaker. So this also means that you can do 480 watts AC per input channel, which means that in general, what kind of panels would you put on these? I'd probably put like 500 watt panels, so that gives you a little bit of clipping. You can go higher, and then I think I want to say 550 is going to be the wattage of the panels if you want to do the 1.2 clipping ratio. I also want to mention that the QS2s are also UL 1741 SB certified. So if you have any utilities that have pretty high or have the requirement, you can use these microinverters to fulfill those grid connection requirements. Just note that our old product, our QS1, is not that, but the QS2 is compliant. The other thing also I want to mention is that the QS2s, there are 4 MPPTs as well. So this means that if you shade one panel, it won't impact the other 3 panels as well. All right, I just want to share this graph as well. In general, I want to compare this with the DS3s. So if you look at I think in particular, these 2 lines here, as you can imagine, because the DS3Ls have smaller AC output, you can actually put more of these microinverters on a branch, and as a result, you can actually put more panels per branch as well. So for a DS3L, you can put 14 panels on a 30 amp, whereas the QS2 is going to put 12 on a 30 amp. So I would say that if you're using smaller wattage panels, I would generally recommend use the DS3L, so like 450 watt panels. The DS3Ls is a better fit because you're going to be oversizing them with your QS2s. However, if you're using 500 watt panels, you can see the clipping ratio on a DS3L is getting a little bit higher than 1.2 that I generally ballpark at. And then even higher is probably better to do QS2s. Another thing also is that if you're installing a system that has a smaller number of panels, I would say that the QS2 is also more convenient to use as well, because you just need to use a fewer number of microinverters for that product. So let's say, for example, if I have a project with just 8 panels, it's probably easier to just use the QS2s because you just put 2 microinverters on the roof as opposed to 4 microinverters on the roof. Yeah, so just to summarize, I would say that if you're using 450 watt panels around that ballpark, and then if you're sensitive about putting more panels on a circuit breaker, the DS2L is probably going to be a better fit. If you're using higher wattage panels, or if you're using a small project, I would say the QS2 is probably a better fit for your project as well. Yep, and then here's another thing I just want to emphasize is that for the QS2, this is generally the wiring, and then here's the wiring for the QS2. One side note is an interesting thing about the quad microinverters is that it was interesting and controversial because a lot of people really liked the quad if you're thinking from a $1 per microinverter perspective, because you're using less power electronics on the system. But from a system installation perspective, a lot of people didn't really like the fact that you had to have whips on these microinverters. So one I generally recommend is that for QS2s or for quads, definitely really helpful for systems where you have a repeated setup. If you have panels that have longer whips, that's a generally better fit for those projects as well. And yeah, so I think that's the main thing I just want to mention for the quads. Okay, I'll pause here. Is there any questions about the QS2s? If not, the next topic I'll go over is the AC combiner box, but any questions about the QS2s?
I'm not seeing anything on the QS2s here, Chris. We're good to keep going.
Cool. So next thing I'll talk a little about is the AC combiner box. So I'll blaze through these three slides pretty quickly. But I just want to sort of set up the motivation for this AC combiner box. One often request that we got from a lot of customers is, can you do consumption metering with external CTs? The easiest way that, or prior to the AC combiner box, we often recommended using the ECUC because the ECUC allows you to stick CTs into the unit itself, and those CTs are then be able to use to do consumption metering. So it basically ends up looking something like this right up here, where you have the CTs of the consumption being plugged in here and the production CTs over here. One thing I often like to remind our installers that whenever you do something like this, just to make sure that you are powering both L1 and L2 so that you're measuring both phases. So as you can imagine, this was a little bit cumbersome and tough to install. So one thing that we basically made it a lot easier to do is to create, I'll skip this slide over here. We made it a lot easier to do is just do the pre-wiring of the CTs and meters into the box in its own already, so that it makes it easier for installers to be able to implement as well. So this is the combiner box, what it looks like. I guess just from a schematic perspective, this is what the combiner box sits. So you basically have your microinverters, your AC string goes into the AC combiner box here, which then goes into your main load center. And then you have your CTs going to measure the solar here, and then you have your grid CTs measuring the input and export values of the system here. What that physically looks like, it looks like this. So inside, you have a ECU inside of here. One note is that this current iteration of the ECU is cellular only, so cellular and Ethernet only. So it currently does not have Wi-Fi, but we do have a future iteration of the combiner box that will have Wi-Fi in the ECU itself. So it will have an ECU, so you don't need to buy a separate ECU. It'll be inside this box itself. This unit over here is a meter, and that meter basically allows you to do CT measurements. So the PV CTs are over here, so you would run the solar in here, and it goes through the breakers onto this box over here. So this will actually replace the load center as well. And then you would also have CTs that are going externally to the main service panel to be able to measure the consumption of the site. One thing is that this is outdoor rated, and it's also UL rated as well. You can put 110 amps of solar onto this box over here. And let's see, this unit over here, the ECU, this 4G ECU, it currently does not come with a SIM card. But we often recommend a company called 1NCE. We like to use that. We like to recommend using that company because they use pre-activated SIM cards, and what you do is just like put the SIM card into the ECU, and then it will be able to start communicating with the unit via cellular. One other note also is that this meter itself is revenue grade as well. So it basically means that it meets accuracy standards. If you have a site where you need to have metering to meet those that has some requirement for higher accuracy, the system will comply because it's ANSI certified. So we'll be able to be compliant with revenue grade requirements.
Hey, Chris, we've got a couple questions here, if I can just interject.
Yeah,
first one here is the monitoring / CTs required in a combiner box?
I would say that it is not required, but I would say that if you don't want to use CTs, then maybe this is probably a good follow-up. So the AC combiner box is not a required product that you need to install on every APsystems system. So if you don't want to have CT monitoring, you don't have to use this box. You can just do what you do normally, which is to purchase an ECUR, and then to bring the solar, you just get like a generic load center, and where you would put your breakers inside. So yeah, the purpose of this box is not to require you to use this, but we just offer it as a solution if you have a customer that wants to have consumption monitoring or anything of that sort to make it easier for you guys to install. So yeah, once again, it's not required to have this device, but it can be helpful for customers that want to have those CC measurements. Hopefully that answers your questions, or and if I interpret that correctly.
Yeah, perfect if another one comes in. And then what is the length of the consumption CT leads, or yeah, what is the length of the consumption CT leads, and can they be extended?
I actually don't know it offhand, but it is possible to extend it. The main thing is just basically to extend it with the right gauge of wire. I apologize, I also don't know I don't know the exact wire gauge offhand for these Ts, but you can certainly extend them. Um, and I would say that for us, we don't have an official number that we use, but we have tested it to we have tested it up to like 100 meters, which is I guess that's oh I forget Canadians you guys use meters, right? Because in Americans I have to translate that to feet. So that's like around 300 feet or 100 meters distance. So we tested at that length before, and it's been okay. Another thing I also want to mention is that if you do extend, just be a little bit careful that you don't switch the phases or switch the wiring of the CTs.
Perfect. And then lastly here, can you just repeat the name of that SIM provider you recommend as well?
Oh yeah, sure. It's called One NCE, so One Nancy Charlie Echo. Yeah, and that's a third party SIM card that I personally like to use, and I generally like to recommend.
Perfect. And then that seems to be all the questions here.
Great, thank you very much. Let's see. Yeah, so basically, here's another just view of the AC combiner box, just from a technical wiring perspective. One thing just to be careful about is that just make sure that the phases are connected correctly. I think a common mistake that a common mistake that often happens is that when you're routing the strings, you want to put all the red wires into one CT and all the black wires into the other CT, which is generally good practice. Just make sure that the red wires do go into the right phase. So say, for example, CT1 is black wires, CT2 is red wires. You feed all the black wires into the slots, say L1. So notice there's a little bit of alternating that happens here because of the S nature of the breaker box, right? And then you would feed all the red wires into CT2, and the red wires only go into L2. So just be cautious about that. We often see sometimes that the colors are correct, but then where they're plugged into in here is often mixed up. This is, let me see, is this a good example? Yeah, this is actually an example of one that was done correctly. Yeah, because if you can see here, this is black, red, and then red, black, and then black, red here, and then all the black wires go into this PC right in here. So yeah, that's just one thing just to be cautious about. One other thing I also mentioned, so this is what it also looks like as well. Strings goes in here, shown over here, and then the CTs basically are going to go into you see, and it is basically connects to the main service panel onto a breaker here. And then this is also where the CTs are going to lie as well. You don't need to do the wiring for the PV CTs because they're already pre-configured, but you will need to do it for the grid side. Yep, and then in terms of this is where the SIM card you will plug into. So in general, I generally recommend having a pre-activated SIM card. If not, just make sure to activate the SIM card prior to plugging in. And in terms of commissioning, there is a QR code that you can use to do the commissioning. Just remember that that if it's a Bluetooth, that this is actually a ECU that you can connect via Bluetooth. So a lot of times what you can do is you hit a local access mode is the ECU that you're connected to. One thing I like to do is that you can do the scanning through here, this button over here, and that allows you to scan the ECU ID on the combiner box itself. So this is how you would do it from a Bluetooth perspective. And what happens is then you go through this connection page over here, and then you can go through the same procedure with regards to claiming microinverters to the ECU. All right. Let's see. I have other information on the AC combiner box, but I think that'll be the extent that I'll go for this unit over here. But if there's any particular takeaways I want to reiterate with the AC combiner box, it's not required for every microinverter project with AP systems, but it is a helpful device that allows you to do CT measurements if that's required or asked from your customer. All right, any questions about the AC combiner box? Otherwise, I'll go over our storage system.
Yeah, we got a couple questions here. First one, so I could use a normal breaker box as a combiner box on a larger microinverter install?
Yes. Yeah, that's correct.
Perfect. And then the last one here, could you please repeat why a SIM card is needed?
Oh, so these ECU is a new version of the ECU, and it's a cellular ECU. So our current ECU, or most of our ECUs, is a Wi-Fi or Ethernet connection. And then this particular combiner box uses a new version of the ECU that replaces a cellular instead of Wi-Fi. That being said, we've gotten feedback from a lot of our customers that they actually want to have Wi-Fi as well as a cellular option. So if you have, we'll work with this on BayWa. So definitely have a conversation with the BayWa rep to make sure that if you're getting AC combiner box, that you're using the one that has the right protocol. Our first iteration of the combiner box was cellular and Ethernet only. So in order to have cellular, you would get a SIM card and plug it into the ECU to be able to talk so you have the unit be able to talk to the internet via cellular communication as opposed to a Wi-Fi connection. However, if you're just using Ethernet, you don't need that SIM card. You can just connect it through Ethernet. And then furthermore, we do have a future combiner box that we actually have in production, and I think we're shipping already. It does have a different part number, so just be cautious about that and just check with your BayWa rep to make sure that you have the right one. But we do have a newer version of the combiner box that uses a Wi-Fi connection instead of a cellular connection. So that's just one thing to just be aware of.
Yeah, and then just one more question here. So the customer needs to pay for a data plan for this. I would assume that the data plan would need to be paid for by the customer,
correct, yeah.
Correct?
Yeah. It depends on the nature of the SIM card that you get. A lot of SIM card, the one that I just recommended, the one Nancy Charlie Echo company, they are basically you buy the SIM card, and it's good for I want to say 10 years or 5 years. I don't remember. I want to say 10 years. And then it comes with a certain amount of data, and then what happens is after some time, when the data runs out, it will automatically top up. Or you could also pre-purchase data onto that SIM card as well. So it depends. So it also depends on like the SIM card that you decide to use. Is how they charge customers.
Awesome, thank you. Yeah, no, that's looking like the end of the questions here for now.
Great. Once again, I want to thank you for all the questions that you're asking. I really appreciate it, and keep them coming. All right, now let's talk a little bit about new residential battery product. So it's called the ELS 11.4K. It looks like this. E stands for energy storage system. L stands for low voltage battery input. So and S stands for split phase. And 11.4K refers to the amount of power that it can produce when it's on a backup mode. So just general features. So in our marketing material, we often use the word PCS, power converter system. I generally don't like using this word because it's often confused with power control system, which is a different concept. So I often like to use battery inverter because kind of like a microinverter allows a DC solar panel to interact with the AC grid. You need a battery inverter to make a DC battery to be able to interact with the AC grid. So it's bidirectional because you need to charge the batteries and discharge the batteries to the grid. It's a low voltage battery system, so as opposed to a high voltage battery. We generally prefer low voltage systems because our microinverters are kind of similar to that as well. The 11.4K, it natively outputs 12 split phase voltage, so it does 120 and 240 volts split phase. The max continuous output power is 11.4 kilowatts. It can do higher peak power, so 17.1 kilowatts for peak. It is possible to have solar when you have a grid outage. I'll talk a little bit more on that front with regards, because there's a couple of caveats with regards to like power. And you can use this unit for both backup uses. So if you lose power, it'll be able to back up your power, or self-consumption. So basically what it means is that when you're still tied to the grid, you'll be able to use the battery to discharge, to discharge during the night times instead of buying power from the utility. And for backup applications, you can actually, the switching is very fast. It's basically imperceptible when you lose power. It'll be able to back up your loads pretty quickly. From a connection perspective, it basically looks like this, where your inverter is over here, connects to the main service panel over here. We need to get some DC batteries that are connected to the PCS. I believe BayWa carries Soluna batteries. So that's one of the recommended solutions that we often partner with. So you get the Soluna battery here connected to our inverter system over here. And then you would have a backup load center over here. And that basically, when you have a grid outage, the loads on your main service panel turn off here. Your PCS basically disconnect itself from the utility to prevent backfeeding, and then you have and then your loads on the backup are stored right over here. A question that often people ask is, as I mentioned earlier, you can have solar staying on when you have a grid outage. So the way that it works is that you connect your inverter system into here. And a lot of people often ask also is that which inverters can you use? Can you use DS3s? Can you use our older microinverters? Can you use another brand's microinverters? The quick answer is yes, because if you AC couple solar into this port over here, what happens is that this port will basically turn on 240 when it wants solar during a grid outage, and then it will turn off that 240 to prevent, when the batteries are full and you have a grid outage, it'll be able to turn off the solar from here so that it doesn't charge the battery to be full. And with any inverter that delivers power to the AC, it will not produce any power if it does not see AC voltage on this port over here. So like any other inverter solution will be able to go into here. Just the main thing just to be cautious about is that there is a power limit that you can put onto this port over here, because this PCS can only handle 11.4 kilowatts. Approximately, that's the amount of power that you can put on this port over here. So if you have a system with like, I don't know, 20 kilowatts AC, that's going to be too much. Just mention also that it's an AC limit. So you can have like 20 kilowatts of DC as long as the AC voltage is below that limit, but it should be okay. Other thing to note as well is that the inverter talks to the router in the homeowner's house. So that's basically so similar architecture to microinverters, where it uploads data to the router, and then you access all the data on the app and on the website. And you're also free to use the website to do remote control and to do data monitoring. One thing I wish I had a video of this. I'll prepare it in the future. But one thing that you can actually do is that if you download the EMA app, not the manager app, but the regular app, if you go into the homepage and hit demo mode, you'll be able to get the test. You'll be able to get a test account, so you can see like the unit functioning as if you were a homeowner, and you'll be able to see like the data that you get available, and you'll also be able to see the settings that you can change. Because it's a demo unit, you won't be able to actually change the units, change the data, but or change the settings, but you'll be able to see what it generally looks like. All right, so I'll pause here, and that's basically all the comments I have with regards to our battery system. Any questions people have regarding our ELS 11.4K?
No questions I can see yet on the ELS unit there, but just one question back to when we were going through the ECUs was just what kind of data consumption does the ECU actually use per year?
Oh, yeah, very good question, because it's contingent on like the plans that you set. I will look that up. It's on the final page of our ECU user manual, where it basically kind of talks a little bit about how much data it consumes. As you can also imagine, the ECU uses a certain amount of data, and then if you have more microinverters, it's going to use more data as well. I'll need to double check to see what that formula is.
Okay, and then one more question came through here as well. If the solar input is greater than 4 kilowatts, what happens?
So what will happen is that the PCS, it will turn itself off to protect itself from overcharging. And what that means is that it will basically shut itself off and it'll stop producing power for the backup. So what that sort of manifests as is that PCS is basically turning itself off, and the customer will see that they're losing power every once in a while. So yeah, that's in general why we don't recommend that's in general why we say not to overload that port.
Okay, and then another one just came through here. Is there plans for a bigger inverter? The 11.4K not getting up to 50 amps at 240 volts limits the backup capacity or capability.
Yeah, actually, we are. It's in our roadmap. I think it's probably hot off the press. Because I don't think we've advertised this. Actually, now that I think about it, I probably shouldn't say anything. A higher power inverter is something we're looking into. Yes.
Okay, perfect. And I think that's it for now. Yeah, we're clear to keep moving here.
Great. Thank you very much for the questions. Okay. All right. All right. So I'll move on. Give me a few seconds to see what I have. Okay, all right. So next topic I'll go over these next things a little bit on a quicker side. I apologize for my briefness, but I do want to go over a couple of new features that we added onto our EMA. First one's called automatic data refresh. So as you know, the microinverters, they produce data every 5 minutes. So oftentimes it would be nice to get a faster response to see if something is working. So so this is only possible when you're on site. And you are in local access mode with the ECU. So there's a feature called automatic data refresh. Is that if you go to the top right-hand corner of your screen, you might see this little swirly thing right over here. If you click on this icon over here, it'll basically start producing a automatic refresh, and then it will start updating the data a lot more frequently to be able to see the effects from the microinverters a lot more quickly. I would say that I think I want to say it's like every 10 seconds that you'll be able to see data from the microinverters. And so this is really helpful if you want to see immediate results when you're trying to change something on the system. One thing, it does not change the NEC 5-minute startup time, because if you remember, a microinverter will only produce power if it sees AC voltage for like 5 minutes, and then it will turn on. So it won't impact that, but it will impact things like if you're shading in or if you're trying to identify other issues, that you'll be able to see that a lot faster. So that's the automatic data refresh. Maybe next time you go on site, and you can take a look and see this icon over here. The second thing, this is probably what you've seen as well, where it basically shows ECU has new software to upgrade. You might get this window whenever you go into the EMA Manager. So you're probably wondering what it is. It basically allows you to perform firmware updates on the ECU without the ECU being connected to the internet. So once you say okay, you will download the firmware from the internet onto your phone, so that the next time that you do a local access mode connection to the ECU, it'll give you the option to be able to update the ECU firmware without your phone being connected to the internet. Yep. So those are two quick notes I want to mention on the EMA app as like two new features I want that you might have might or may not have seen. Any questions on those two features? Otherwise, I'll go over EMA features.
Nothing in the question box here.
All right. So two quick points I also want to mention. So on the EMA, we recently released, well, not recently, we have this tool that I want to talk a little bit about. It's called the AP Designer app. It basically looks like this. If you go to the top of your screen and you hit AP Designer, what you can actually do is you can build out like 3D models of buildings, and you can place panels on the rooftop. This also does like ray tracing to be able to see production estimates, and you'll also be able to use this to sort of produce your microinverter layouts. And then based on the layouts that you create, it'll be able to generate a BOM for you. So it'll tell you how many microinverters you need, how many DC extensions you need, how many bus cable you need, and so on and so forth. So I really recommend using this as a nice tool to be able to see, like for certain projects, what your product quantities, quantity will sort of look like. Yeah. So and you can also see in terms of the production estimates for the sites that you use. Another thing I also want to mention as well is that we also expanded our training resources as well. So we recently created Academy, the APsystems Academy. So if you go to academy.apsystems.com, you'll be able to create an account to be able to take some courses. It's basically a bunch of self-guided videos that you can take quizzes at the end, so that you'll be able to get certifications for. So this is mine that I got for the ELS 11.4K. We currently have 2 courses right now, which is the ECU/EMA installation training, and the second one is the 11.4K training. So really recommend both of these. Regular customers of APsystems, generally good to take it just to have a good refresher and review, and just general confirmation that your understanding of our products is correct. So yeah, these are self-serviceable, and you're free to use as well. Let's see. I think this is the final slide that I have for today. Also, is that if you're not an APsystems customer already, the number one thing we often recommend do immediately is to register for an email account. So you can go into here. If you search up a register email account on Google for APsystems, you'll be able to fill in this form over here, and you'll be able to submit a request to get an account. And once you get an account, you'll be able to start adding devices and products into the system. Okay, so I'll pause here. That's the end of the seminar, end of the slides that I have for today. So I'll open up the forum for any particular questions that people might have about any of the content that I just went over for today.
Yeah, sounds good. Thanks, Chris. I'm not seeing any new questions in the box here, so for now I'll just get going here on my outro. But yeah, no, I just wanted to once again say thank you to APsystems and Chris for chatting with us here today. They are a great partner, and as you can see from everything they touched on here today, they got a great lineup of products as well. Their technical team is top notch, so please reach out to your BayWa rep or them directly if you need to get in touch with them for any specific questions. We always have great stock of APsystems in our warehouses across Canada, and we encourage you to check out our web shop for specs, manuals, inventory, and pricing. And please be sure to check out our full webinar schedule on our website as well. Yeah, I'm just going to wait a minute here just to see if any questions come in. To make an installer account, it's asking for a contractor business license. What would this be?
It's usually like some sort of like electrician's license to basically prove that you are licensed to be able to operate in that region as an electrician.
Perfect. And then another one here, what application do you recommend using the DS3H microinverters in?
Oh, yeah, so the DS3H is so it's kind of similar to that of like a QS2, where the QS2 is generally good for like higher wattage panels. So I would say that I would use the DS3H for higher wattage panels as well. Since I believe the AC output is I want to say 1050 AC, if I recall correctly. So it's good for those applications.
Perfect. Thank you. Yeah, I'm not seeing any other questions coming in here. So, yeah, I can answer that one. Yes, there will be a copy of this webinar available on our YouTube channel here after we're done here. Yeah, I'm not seeing any other questions coming in here. If you guys do have any other questions, please reach out to your BayWa rep. But yeah, no, I hope everybody has a great day, and thank you again so much for taking the time to learn more about us and our friends at APsystems. Actually, here, one more question. When can we expect an update to the EMA portal was the last one here.
We don't have any significant updates to the. I'm guessing is referring to the UI the EMA portal. We haven't. We're looking into it, but we don't have any immediate plans to doing any like larger updates quite yet.
Okay, perfect. It's looking like that's it for questions. Yeah, if there's any other ones, please reach out to your BayWa rep, and yeah, have a great day, everyone.
Thank you.